What do you say we test? Yes? Even though if you've got really good eyesight, you can already tell what the decision's going to be based on what Excel shows up here. But we'll come back to that. So what we're going to have to do is run this data into our TIs to crunch it. So let me do this. Let me
clear out our old list, right?
You can clear out the old list, yes ma'am. But we do have to do a little computation, don't we?
Mm-hmm.
Why? We have to count and also compute. Why is that? How many lists do we have to enter? L1 and L2, correct? So L1 is going to be the observed list, and L2 is going to be the expected list. So we know what the observed list is. The observed list is what we just saw. And in case you can't read it, we saw 173 red. We saw 314 orange. This is red, orange. 370 blue, DL. 332 green. 216 yellow. And 122 red. Wait, that's brown on top, sorry. None of that matters. It kind of matters, but not really. So brown on top, sorry. 173 brown, 122 red. That's a big 2, not sometimes strange hieroglyphic symbol. And it's brown, BR. The other great thing about goodness of fit, it allows us to test qualitative data, right? We're actually testing qualitative data, colors. How many of each color? It's numerical because we're counting it, but at the same time, it's qualitatively categorized. Good. So, what goes over in the L2E space for that? What we're expecting to get, yes. And Darla's pointing over to the null hypothesis. Thank you, sister. Yes. So she's pointing over to the research or the null hypothesis. She says 30% brown. Yes, 30% brown. So how do we use that? What do we put right here?
30% of what we all have.
Yes, exactly right. We have to make sure the unit here agrees with the unit here. The unit here is candies, 173 candies. We can't put just 30% here because that would be a percentage compared to candy. So we have to first figure out is how many overall candies did we have? And I believe I have that in Excel. I've got 1,527. I think that's right. Trust me. Trust Excel anyway. So what has to go here is 30% of that. Does that make sense? Remember how we did 5 songs on the iPod randomizer? We did 5 because that was 10% of 50. We saw 50 total songs shaken through. 10% of that was 5. So here we have to put 30% of the overall total 1,527, which should be 458. Damn, you guys are good. 458.1? Does the 0.1 bother you? Yes. Yes and no, good. Well, you can't have 0.1 of a candy, but you can what 0.1 of a candy? What? You can eat 0.1 of a candy. I was thinking of a different verb starting with A, ending with verage. That's right. You can't have 0.1 of a candy, but you can average 1/10 of a candy, right? You can average it. That's what expected. On average, expected 458.1, which is exactly 30% of 1527. Fair enough? Okay, we saw 304. So in other words, I guess what I'm getting at here is, friends, the numbers that go here don't apply the percentages to the observed. You don't apply the percentages to your observed because the observed is what you saw, not what you were expecting to see. Is that believable? Yeah. Good. Okay, orange, we should have seen 10%. So that should be 152.7. Let's move the decimal place over 1. Fair enough?
But couldn't you in L2 put it in like that and it'll calculate it?
You can. Absolutely, Beth. You can put it in L2. You can put 0.3 times. You want to just do it that way? We can totally do it that way. If you're using L2, yes, you can use L2 as a spreadsheet. If you don't want to crunch these numbers out, we'll do it both ways. I'll put it on the board too so we have a reference. No, the answer is yes, for sure. For sure you can do it that way. So if you want to go into stat, I was already there, and you want to put your observeds and your expecteds, so you put 173 and so forth, 314, 370, 332, 216, 122. I do. 332, thank you. So what Beth is asking is, instead of doing the math like on paper and then putting it in, can you just put in L2 0.3 times 1527? And of course, Absolutely. 0.1 times 1527. Absolutely. And so forth and so on. You can totally do it that way. Absolutely. Does that make sense? Use it as a spreadsheet. Use it as a spreadsheet. I'm gonna fill in the rest of them here. Blue is also 10, right? Yeah. 152.7. And one of them else is 10. Green, 152.7. And the other ones should be double that, I think.
305.4.
Thank you, thank you, thank you. 305.4. 305.4. And that's what you're expecting. That's what you're expecting. Beautiful. You don't have to worry about clearing L3. L3 will take care of itself. The program, the first thing it does is it wipes L3 and then replaces it with the new L3 values. Yeah, Dustin.
How do I get it back?
Stat. Yep, that's it. Stat 5, enter, and it's back. You may have to press enter twice. I'm not sure. No, stat 5 enter should do it. That should be back there for you. And it's okay, friends. The reason I wrote this program the way I wrote it, you can use different lists if you want to. Remember how it asks you what lists to use? You can put L5, L6, L3, L4, whatever you want to use. It will always put stuff into L3, just so you know. But you can use any lists you want to. Yeah.
So now we can do the goodness.
Now we are ready to actually test the data. The data collection, as it always is the most time-consuming part. We're ready to test it now. Exactly. So let's swing over to here. We've got our hypotheses. Let's get our test statistic and our p-value. And let's see if we believe M&Ms. And when I say M&Ms, I mean the Mars company that gives us those percentages. Everybody good with the data? Got them in L1 and L2, yes? Or wherever you have them. Program, Goff. Tell it where your data is. Observed is in L1. Expected is in L2. Okay.
I thought I messed up. Evaluate.
I know. It's like, oh, God, what they're doing.
Okay.
I'm only sitting here thinking.
Test statistics, about 1,003, it looks like, about 1,004. What is that? Huge. Doesn't matter. It's huge. They're calling the p-value 0. Can you see why they're calling the p-value 0, friends? There's your curve. There's your curve. Where did we land?
1,003.
We landed over in
La La Land.
Ochiko. We landed at 1,000. Look, 0. This is essentially 100 right here. That's 100, which means here's 200. Somewhere out there by that piece of art is 300 or 400. Somewhere on the sidewalk is about 500. Somewhere in Ochiko's front lawn there is 1,000. Should we be on that curve?
Yeah.
No, we are on some ridiculous other curve. We are not on that one though. That is the Mars curve. That is the acceptable variation in Mars color percentages. This is not the curve we believe we are on. We believe that at least, now the problem is, this is the problem with this. It says, who do we believe? What's the conclusion? What's the conclusion right now, friends?
It does not.
Well, okay, Mars has no idea. I like that. Say it a little more statistically. We believe H1 that at least one of those percentages is off. But here's the question.
So we just,
You can just, right, you basically, you can't support what Mars is saying.
Right.
It appears Mars is off, right? It appears Mars is off. But what question has not been answered?
which one, how much?
Which one and by how much? 2 questions actually have not been answered. And that is part of the problem with a goodness of fit test. Just so you know, the p-value isn't exactly 0, actually it's
But
rounded.
do we really care which one is off and by how much? Because we just proved that it is off.
Well, no, Ben, the question is a good one. The question is a good one.
It doesn't matter.
Do we care which one is off? Now, with M&Ms, not so much. Although we're going to look at it right now and decide which one we think is off. We can look at it real quickly. But here's the deal. It's not so much whether we care about the M&Ms. It's whether we care about, there's been a spike in flu rates in southeastern Oregon.
Or like the spread of herpes.
Or something like that, right? Or something like that. Why is it that this county that Birmingham, Alabama, the county that contains Birmingham, supports state senate, while the other counties are at the exact same percentages they've been for years? Yeah, the M&Ms is a bit of a superfluous example. But when you take it beyond the superfluous of M&Ms, you begin to realize sometimes you do want to go back and see which one changed and by how much, as actually said. Yes. Very good question.
Mars to the wall.
Yeah, well, ish. Or just write another letter. So now you see why I'm writing the letter, right?
Yeah.
You see why I'm writing the letter. I'm writing the letter because this always happens. Now, the question is, and we're not going to go through this in class. I've learned not to do this in class. I included it as a homework example with step-by-step processes, how to find the ones that are off. Now, here's a non-rigorous way of finding the ones that are off. Go back to your stat editor in your TI and look at L3. Remember what L3 is all about, friends? Remember L3? Yeah, L3 is our buddy. L3 is an example, or L3 is a measure of the individual offness. The bigger the numbers in L3, the more off the numbers were from what we were expecting. Remember that? With the iPod randomizer, we saw more Queen than any other song, and that L3 value was the largest. Although, when you think about that, largest value was 3.2. It pales in comparison to what we're seeing here. Look at these numbers. Look at these numbers. Which one was off the most? Is that this guy, the 309 right here?
Yeah.
Right, 309 is the largest variant, that was blue, you guys said?
Yeah.
Right, and if you remember, we were looking at the individual proportions. They were all goofed. Blue was supposed to show up 10% of the time. It showed up more like 20 or 25% of the time. Right? Now the question is, this guy, who's this guy?
Yellow.
That yellow? Yellow apparently is pretty close, at least relatively speaking, to what it should be when you compare it to the other quantities. But here's the deal. We know at least one is off. So clearly it's blue. But what's the next one? Is that off as well? Is that off as well? Well, it's hard to quantify that without doing something called what's called post hoc test. Post hoc means after the fact. So you've run the test, you know something's up, at least you think something's up. But a post hoc test allows you to do is go in and test individually to find out which ones, if any, which ones are off. At least one is. That's all we know though. At least one is off, and at least blue is off. The question is yellow, not yellow, is the one below blue, whatever that one is, which I forget. Is green also off, or is that within acceptable margins? Susie?
So it would have to equal 0 for it to not be off.
It would have to equal 0 for it to be in perfect agreement. The question is it off by too much of a significant amount? Remember, there's wiggle room. When Mars says we should have 10% orange, that doesn't mean you can't have 11%. 11 might be close enough to 10 within a margin. But if you're getting 22% when you're expecting 10, I doubt very much the margin's wide enough to include that in the interval.
Where do they have that written down?
Say that again?
Where do they have that written
On
down?
their website.
It says you'll have 10%.
And they say due to, what Ashley said, due to consumer surveys.
Oh, okay.
Due to consumer surveys, we've decided this is the most appealing color distribution. Beth, ask me that question.
Oh, I was just gonna ask, well, what would make it enough, significant enough to be statistically?
Off. How far off is off? You can run one prop Z ins on each one, but remember the problem with that?
You reduce your confidence.
You reduce your confidence. So what you have to do is you have to account for that by using what's called a Bonferroni correction. I talk about this in one of your homework problems. So you'll actually walk through and you'll see you have to adjust the confidence to make up for the loss of confidence later on.
What would the confidence level be? Because like at 2,
It would have to
make
be.
it a 90% confidence.
You'd have to do the same thing on your first thing. Go to algebra. You have to go point. You'd have to go x to the 6. Here we go. You can do this. X to the 6.
I bet you wrote this question.
X to the 6 equals 0.95. If you want to be at 95% overall, whatever confidence raised to the 6 gives you the 0.95. Which you have to be higher than 0.95 to get down to 0.95. It's the same thing I made you guys do at your first exam. It was the least liked problem on your first exam, if I remember correctly. Well, it was a little bit of algebra. Teeny bit of algebra. Tiny. You didn't like it very much. I apologize. But if you care and you want to know where the differences are, that's what you have to do. Now, please, friends, if you take a look up here at the screen, I'm going to put the other Excel spreadsheet back up. I've also run the other test. With the other distributions, it's a little hard to see because the font's kind of small. Let me make it bigger. So here are the same results we just got. Here are the same results we just got. Right here, you might recognize some of these numbers. There's our observed. Here's our expected, just like we got. Here's our L3 values. They look very similar to those we got over there. Okay, they're out of order, but...
They're actually like going down.
Well, exactly, because they're doing the same computation. It's the same computation, except you guys don't have Excel in front of you necessarily. So here's your test statistic, 1003.8, ridiculous. There's your p-value. Notice it's not 0. It's 0.21409. So that's 0-ish, right? It's basically 0. It's essentially not there.
Oh, I read it now. Okay.
You can say it's to the 10 to the negative 215th power, which is ludicrous. Just so you know, that's like flipping a coin 711 times and getting the same thing every single time. Heads, 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 heads. Would that happen on a fair coin?
No.
Shouldn't, but that's the likelihood of it happening. That's like rolling a six-sided die 275 times and getting the same number every single time. If that happened, what would you think about the die that you're holding?
It's weighted.
That it's weighted, obviously. What do you think about the coin? This is my personal favorite. It's like take a deck of cards, shuffle them up, deal them to Karen. 5 cards. She pulls them up. Oh, look, I got a royal flush. Now, that right there is extraordinarily rare, right? Getting a royal flush dealt to you. Getting this likelihood is like having that happen 37 times in a row. Is that going to happen? Not with a fair deck of cards. Not unless that deck of cards consists of the 5 cards you need on the top. That's the more likely. So what I'm talking about is all those situations I'm describing exist way the hell over there in Ochako at 1004. Not down here. Well, you can't see it anymore because I've taken it off, but that beautiful curve of deviation curve over here. Does that make sense? Yeah, we're remote. I don't know what you're doing. It's the same key opens, so it's okay. Now here's the deal. Mars sometimes gives me these color distributions. Sometimes they give me that there should be 13% brown. Oops. Top row brown. Okay, choose a different one.
Sean, I have
Yes.
a question.
Go ahead, Lynn.
Is it supposed to be 100.4 or 1,000?
It's 1,000.4. It's 1,000. It's 1,004 point something. It's 1,003.8. Sorry. Regardless, either one's off the curve. That was just more off the curve. Yeah, I transposed the decimal point wrong. Sometimes they tell me this should be 13% brown. They tell me 10. I can't read that. 10% orange. No, keep up here. 20% orange. 24% blue. Let's see. 16 green.
14 yellow.
14 yellow.
13 red.
And whatever's left, red, 13. Sometimes that's what they tell me it is. And again, sometimes, like I said, the newspaper clipping I found from 1990 was this distribution down here. But sometimes they include this in their little form letter they sent back to me, which is kind of fun. So I tested that one too. Hell, let's test that one too. And you would do it the exact same way if you were doing it yourselves. The only thing that would change is what you put into L2. Can you see why?
Yep.
You have different percentages. You would do it the same way, you would just get different values. Because instead of expecting 30% brown, you'd expect 13% brown, which equates to 198.51 browns on average. So notice that the numbers are different here. Now what's cool about that is when you look at the L3 column, which is a little hard to see because it's great. I'll make it bigger so you can make it dark too. Notice there's much more agreement with that distribution. Those off numbers are a lot less off. Some of them are very, very, very damn close. Look, yellow is almost spot on, as are orange and blue. Almost spot on, almost zero deviation. Pretty rad, right? Brown's not bad, 3.2 compared to some of these hundreds down here. But then look at green and red, 31 and 29. Now, friends, interpret. The test has been run. Here are the results of our test, using the other distribution. Does this counter our original conclusion that we think Mars is off? Or do we still think Mars is off? What do you think?
It's still up.
Mars is still off, isn't it?
Yeah.
Look at that p-value. 1 times 10 to the negative 12. 0.00000000001. That's like flipping a coin and getting the same thing 39 times in a row. Not as impressive as 700 whatever the hell it was, but still ridiculous. That's like rolling a die and getting the same thing 15 times in a row. Again, not as impressive as whatever it was, but still ridiculous. It's like getting double royal flush twice in a row. Again, not as impressive as 35. But if you got double royal flush twice, do you think the guy sitting next to you playing poker is going to ask you to leave?
Yeah.
Yeah.
Probably.
The casino will.
The guy at the casino will. The big guy named Bubba's going to get you the hell out of there, right? Exactly. That's the problem. That's the problem. When things are this unlikely to happen, then they shouldn't happen. But yet they did. And if they did, that means something contradicted an original belief. And that's the whole point of hypothesis testing. We had an original belief that we then contradicted. Pretty rad, huh? Pretty rad. That's a good as a fit. Totally rad. So, this is why we have the letter that I'll have you guys sign on Tuesday. I'll type it up, I'll put the new data in, put a new conclusion in, new results. I love including this. I always include these now because I think I told you guys years ago I had to do math for a court case on an Earth Liberation Front fire. Maybe I didn't tell you about
Yeah.
this. I did tell you about this. This was the only way to make the judge understand the math. Would you think something was wrong with a coin? If you flipped it 60 times and you got heads every time. Well, of course, the coin is biased. Boom! Found my connection. That was how it made sense to him. He wasn't buying the statistical analysis, which is the problem. That's the problem with a non-statistical literate society. They don't understand what significance means, but they know what a faulty coin looks like. Yay! So we make that connection. Always think of explaining stats to your neighbor while you're out there trimming the bushes. About coins, cards, gambling. We all understand that. So put it in terms of unlikeliness in that. Fair enough? Decent? You got that secondary glazed look, beyond which I know we stop. So, let me just paint the picture for Tuesday. There's no point starting the next thing right now. It's dumb. What's the next and last thing we're going to talk about, starting on Tuesday and finishing on Tuesday? What's the last setup we have to talk about? Ashley, what are you thinking? Well, math, yes, of course. When we have multiple averages. Beautiful. That's the last thing to talk about. I know there's something else on your homework assignments. We'll just skip it. It's called independence testing. Totally freaking cool, but we can just leave it off. It's totally fine. More than 2 averages. We've done single averages, single proportions. Double averages, double proportions. More than 2 proportions, yay. We'll do more than 2 averages on Tuesday. That way it leaves Thursday for a big old review day. Basically go over the entire back third of the course. Make sure we know how to run all the programs. Make sure we know how to get all the data in. But for Tuesday, bring golf questions for me, right? Goodness of fit. Make sure that you can run the programs, get the same results I'm getting in your homeworks, right? It's pretty highly tech dependent. I want to make sure you guys can run them successfully. Coolio? We'll catch you guys. Have a good weekend. We'll catch you on Tuesday.